All right, welcome to Notes on Relations and Functions. You should have completed the online activity where you were trying to determine when something was a function and when it wasn't, based upon what its graph looked like and what their ordered pairs looked like, what the table looked like. Just a little refresher on that. The very front of your packet has a function machine, and I just want to remind you that when numbers go in the function machine, each number goes in, something happens, the equation happens, multiplying, adding, whatever the case may be for that equation, and then out comes the answer, okay? Or with our chicken that was on the front page, in went the worm, out came the egg. So we're going to be talking about inputs and outputs and all other kinds of good vocab terms. Vocab isn't always the most exciting thing to discuss, but we need to discuss the vocab so that when we're all using these terms throughout the unit, we know what we're talking about, we're all on the same page. So what I'm going to do right now is kind of go through each item and discuss it with you. The first thing I want to discuss is what a relation is. Okay, and a relation has a relationship between two things or two sets of info. Okay, a relationship between two sets of info. Could be like names versus heights. And I don't know if your name has any kind of relationship to your height. It may or may not. Could be your arm span to height. That could be an experiment. Does arm span and height have a relationship? It's just when two things are being related to each other. At any time during the notes, if I'm going too fast, just pause it and then go ahead and fill in your notes and your words. A domain is the set of all the inputs. And you can see that I've circled the letter D and the letter I. And I'm going to tell you about that in a second. But D and I go together because they're the first two letters in the alphabet in relation to the next one, which is range and output. So the range, first of all, is the set of all of the outputs. Okay. Now sometimes kids can't remember, does the domain, the outputs, how does that work? So I've circled the D for domain because it comes before R, and the I in input comes before O in the alphabet. So domain is the set of the inputs, range is the set of the outputs. All right? So then our next two are just defining what an input and an output is. So an input is the number you plug into the function, okay, into the function machine, into the chicken. That's usually the X, but it's not always X. It could be a different variable, but in general we use X for input. The output is the answer, the thing that gets spit out at the end, the Y value. All right, now one last term is function. And a function is the rule that the input follows to make an output. It's a well-behaved relation. The rule that the input follows to make an output. And it's a well-behaved relation because it follows this rule every time. It doesn't change the rule in the middle. It just keeps doing what it's told to do. Each time an input comes in, it does this rule and spits out an output. Now, a side note that I have over here is that all functions are relations, but not all relations are functions. So what that means is, on that activity you just did, there were lots and lots of relations, but only some of them were functions. Now, if I tell you something's a function, you know it is a relation. Okay, now the one other thing I want to tell you about a function is there's a little trick to this function. We know something's a function if each input can only have one output, and the trick is that X can't repeat. So something is a function if each input has only one output. And our little trick is that X is not going to repeat unless it's the same Y value, and we'll talk about that later. We can't use X can't repeat as our official rule, but that's going to be one that's going to help us out later. Okay, so we are going to continue on with example 1, and yes, I am skipping the vertical line test, but we're going to be back to it in a second. So let's go down and talk about example 1, which is identifying the domain and range. So it says identify the domain and range of the relation represented by the table below that shows one Norway spruce tree's height at different ages. Okay, so the age is X in years, the height is in feet, and that would be our Y value. And so it says the relation consists of the ordered pairs. An ordered pair, remember, is X comma Y. Those are what we were graphing in that in the coordinate plane notes that you took last class. And the ordered pairs that we have are literally writing these out in the X comma Y form. So 5 comma 13 with our parentheses around it. 10 25. 15 34. 20 43. 25 52. 52. Those are our ordered pairs. Now the domain is all of the inputs, so that's all of the X's, all of the inputs. So we're going to list them out in numerical order down here below where it says domain, and we're going to use little bird brackets. These fun little brackets. I call them bird brackets because if it was a bird flying in the sky, that's how I make my birds anyway, because I'm a math teacher, not an art teacher. So anyway, it's all of the X's, 5, 10, 15, and so on. So 5, 10, 15, 20, 25. And then the range is the set of all the Y's or all the outputs. So each one of those went in. And then we have a unique range here of 13, 25, 34, 43, and 52. So that was identifying our domain and range. Okay, so we're going to turn the page here, and I have a joke for you while we're turning the page. It says, how do you fix a broken jack-o'-lantern? Any guesses on how you fix a broken jack-o'-lantern? You use a pumpkin patch. I know, the crowd is roaring. It's hilarious. It's kind of great giving notes by myself and no one's laughing. Okay, so example 2, now that we're over that fun. It says represent the relation as indicated, and they want us first to draw a graph and then to draw a mapping diagram. So to draw our graph, we're going to just plot those points out as X comma Y values, just like we did in the previous lesson. So -3, 2, we start at the origin. We go left 3 and up 2 and make our point. The next one's -2, -2. And then go ahead and finish up the rest of the points on your coordinate plane. When you're done, they should look like that. That's one way to represent a relation, by mapping it on a coordinate plane. The second way is we could make a mapping diagram, and that's what these little bubbles are. And it says list the inputs and the outputs in order. Draw arrows from the inputs to their outputs. And when we do this, I like to list them in numerical order. And our inputs are -3, -2, 1, and 2. And you'll notice that I only wrote the number 1 once. It happened twice in the listing of ordered pairs up here, but I only need to write it down 1 time. The outputs were all the Y values, and they were -3, -2, 1, 2, and 3. Okay, so now I'm going to draw arrows from each input to its corresponding output. So up here, -3 produced a 2, so we draw an arrow from -3 to the output 2. -2 went to -2. 1 went to 1. 1 also went to 3. And then 2 went to -3. So that would be another way to represent this using a mapping diagram. So this was part 1 of your notes. I'm going to go ahead and pause this and start up again for part 2 because YouTube won't let me post a video any longer than 10 minutes. So we're going to pause.